multiwire branch circuit, or MWBC, serving a laundry circuit raises important questions about code compliance, particularly in the context of a basement remodel. While it may not be explicitly prohibited, there are critical factors to consider. The National Electrical Code, or NEC, provides guidelines for safe and effective electrical installations. A multiwire branch circuit typically consists of two or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, which is connected to the neutral or grounded conductor of the system. Multiwire branch circuits can share a common neutral conductor. However, there are specific requirements for their installation and use. Firstly, all conductors of the multiwire branch circuit must originate from the same panel board. Secondly, the circuit must be protected by a device that opens all ungrounded conductors of the circuit simultaneously at the point where the branch circuit originates. This is often achieved using a 2-pole or 3-pole circuit breaker. Thirdly, the neutral conductor must be sized appropriately to carry the maximum unbalanced load. Fourthly, if the conductors are installed in a raceway, cable tray, or cable, all conductors of the multiwire branch circuit, including the neutral conductor, must be grouped together. In the context of a laundry circuit, several NEC articles come into play. Article 210.11 C2 specifies that at least one 20-amp branch circuit shall be provided to supply the laundry receptacle outlet or outlets. This circuit shall have no other outlets. Article 210.23 A2 addresses the permissible loads for a 20-amp branch circuit. It states that the total cord and plug connected load shall not exceed 16 amps. If the laundry circuit is part of a multiwire branch circuit, careful consideration must be given to load balancing. If the laundry circuit shares the neutral with other loads, the neutral conductor must be capable of carrying the maximum unbalanced load. This means that the neutral conductor must be sized to handle the difference between the loads on each ungrounded conductor. If the loads are not balanced, the neutral conductor could become overloaded, leading to overheating and potentially a fire hazard. In some jurisdictions, local amendments to the NEC may impose additional requirements or restrictions on the use of multiwire branch circuits for specific applications. Therefore, it is essential to consult with the local electrical inspector or authority having jurisdiction or OJ to determine if there are any local requirements that apply to the laundry circuit in the basement remodel. Considering that nothing else is on the laundry side of the multiwire branch circuit, this simplifies the analysis somewhat. However, it is still crucial to ensure that the multiwire branch circuit is properly installed and protected. The two ungrounded conductors of the multiwire branch circuit must be connected to a 2-pole circuit breaker. This ensures that both conductors are disconnected simultaneously in the event of an overcurrent or short circuit. The neutral conductor must be properly sized and connected to the neutral bus in the panel board. The laundry receptacle outlet must be GFCI protected. Ground fault circuit interrupter, or GFCI, protection is required for all receptacles serving laundry areas. This helps to protect against electric shock hazards. The conductors must be properly sized for the load. The minimum conductor size for a 20-amp branch circuit is 12 American wire gauge, or AUG, copper or 10 AWG aluminum. The conductors must be protected from physical damage. If the conductors are installed in an exposed location, they must be protected by conduit or other approved means. The multiwire branch circuit must be properly identified. The panel board must be labeled to indicate that the circuit is a multiwire branch circuit. If the multiwire branch circuit serves other loads in addition to the laundry receptacle outlet, the other loads must be compatible with the use of a shared neutral conductor. Certain types of loads, such as electronic equipment, can generate harmonic currents that can overload the neutral conductor. If the laundry circuit is part of an existing multiwire branch circuit, it is important to inspect the existing wiring to ensure that it is in good condition and meets current code requirements. This includes checking the insulation on the conductors for damage, verifying that the connections are tight, and ensuring that the circuit breaker is properly sized. If the existing wiring is not up to code, it may be necessary to replace it. Firstly, ensure compliance with NEC Article 210.11. C2. Mandating a dedicated 20 amp circuit for laundry receptacles. Secondly, verify that the multiwire branch circuit conductors originate from the same panel board and are protected by a 2-pole breaker, ensuring simultaneous disconnection of ungrounded conductors. Thirdly, size the neutral conductor appropriately to handle the maximum unbalanced load, preventing overloading and potential hazards. Fourthly, if conductors are in a raceway, cable tray, or cable, group all conductors of the multiwire branch circuit together, including the neutral. Fifthly, ensure GFCI protection for the laundry receptacle outlet, adhering to safety standards for damp locations. Sixthly, size conductors based on the 20 amp circuit requirement, typically using 12 AWG copper or 10 AWG aluminum. Seventhly, protect conductors from physical damage by using conduit or other approved methods, particularly in exposed areas. Eighthly, properly identify the multi-wire branch circuit at the panel board, indicating its configuration. Ninthly, assess compatibility if the multi-wire branch circuit serves additional loads, considering potential harmonic currents from electronic equipment. Tenthly, inspect existing wiring for damage, loose connections, and proper breaker sizing, upgrading as necessary to meet current code requirements. The legality of using a multi-wire branch circuit for the laundry depends on adherence to these requirements. If all conditions are met, it is generally permissible. However, failure to comply with any of these requirements could result in a code violation.